Very good.
So, hello everyone. Welcome to my session. This is going to be a journey of how I migrated a small audio application from UWP to a Blazor WebAssembly app. A bit about me. So I'm talking to you live from Lyon, France. I hope that you're all doing well. I would also like to thank CloudGen and their team for allowing me to perform this and all their support that they've been giving me so far. So let's start. So a bit about me. My name is Damien Dallaire. I've been an MVP since 2016 as a Windows developer, development, sorry. I've been working for Dailymotion as a chapter lead on the Windows and Smart TV since 2014. Here are my Twitter, at Dallaire. You can find me also on GitHub and on LinkedIn if you're interested. So a few slides just about Dailymotion in case you don't know who we are. So Dailymotion, as many of you have probably heard, we rebranded actually in 2017 to become the home for videos that matter. What does this mean? Basically, we're trying to bring content to you to really so that you're interested in what you're seeing. So a few numbers. Dailymotion is 3.4 billion video views per month, 350 million unique visitors per month, and 150 million videos in the catalog. We've got a public REST API, which can allow you to create data from our analytics, from our player, from our explorer, and you can also upload videos. We've got an awesome developer portal at developer.dailymotion.com, where you can find all of our different samples so that you can use our platform. So let's get to the heart of our subject. So what was the point of this session? The point of this session again is how it was easy to migrate a UWP application to Blazor. So first off, I had a radio application. Everything was inside my UWP application. Wait, I'm seeing a message. Is everything okay? Yes. So everything was one big app. So I had my API, I had my assets, I had my controllers, my converters, database, everything. Everything was in there. It worked. It worked very well. It worked out of the box. People are using it, but I had to split this up so that I could actually use this in WebAssembly, because as you can imagine, UWP components, as of the UWP components, so XAML components, don't work in Blazor WebAssembly. So what did I have to do? First of all, I had to start out by moving all of the views into a shared project. This is not really necessary for Blazor. I could have left them, but the most important part was that I moved the API calls, the models, the services, and some view models to a .NET Standard library. The .NET Standard library is a library that allows me to be used on UWP and Blazor WebAssembly. So this is the audio.shared file. So this is mostly used for my UWP app, where it has all of the UWP content. It's not really interesting for Blazor as of today because this won't be reused. However, if you were using Uno, framework made out of Montreal in Canada, this could have been interesting, but this is not the topic today. So this is part of the code that was that is going to be interesting to us later on. So I created an audio.common .NET Standard library. And basically I put in all of my API calls, my helpers, my models, my services, my view models, basically anything that that would need to be reused and that could be reused was put in this library. So going a bit deeper down, what does this mean? So all of the caching services, all of the API exceptions, the exception types, the HTTP calls, how we could do the HTTP calls, the discoveries, the different requests, and so on. Everything that could be shared was really moved into this library, which would really allow me to just reuse it and not have to recode it later on for WebAssembly. Also, some of my view models I was able to reuse, not many, because some of them were tightly coupled to my UWP project, but some of them were migrated. And basically, I was able to reuse 50% of my code. So that was a great win, as you can imagine, because you don't have to recode everything. And this could be used on, and this is used actually on my UWP app and on the Blazor app. So here's the rest of the services. So the analytics, the app messaging, the database, the error messaging, localization. My audio app has favorites. So basically you can put specific radios into your favorites so that you can access them quickly. And it also has a history location where basically it just lists all the different radios that you followed. These use a local database on UWP, and on Blazor, these would have also used a local database. And here are some of the view models that I was able to migrate. So my favorite favorite item entity model, the genre, because you can also search by different genre inside the application, jukebox, and the radio items, and the constants. Let's get on to building the Razor app. So I went into Visual Studio, select new project, file, new project, Web Blazor assembly app. What did I add inside this assembly app? I added my audio.common.NET standard library, and I also added MVVM Lite STD 10. Why did I add this? Basically is because all of my services inside Common are using injection, and MVVM Lite, was what I was using to populate these. So here are the references of my application. So here we're going to go over migrating API calls to get the radio feed information working. So basically, I added a view model to my Blazor application. This view model was called Radio Dashboard View Model. I had to create it as an interface so that I could actually inject it inside my index.razor file. We'll see this later on. Don't worry, I'm going more or less quickly over the slides and the code, and then afterwards we'll go over the same things but inside the app. So what happens here is when you load the index.razor file, you're injecting the iRadio dashboard view model, and once the page is loaded, it calls the get all themed radio async. I will agree with you that most of the wording here is not perfect, but at least for this demo, it worked out pretty well. So I'm adding my code. All the services are empty, basically. This was just to get everything working quickly. So the cache service basically returns that there is no cache. The error, if you're using the error service, just responds empty. And my services radio and my favorite radio service also responds empty. As you can see here, everything is empty. Basically, the idea was really to try and get everything working at first. And then once everything worked, it was to try and get things to add on. For example, later on, I'll show how I was able to add the cache services to get it working using a library. So next, I started using Blazor components. As you can see here, this is the index.razor file. So it's got a, it's basically going over all of my horizontal entities, and then it's creating the radio cards. So here we've got a lot of code for, we've got a lot of view code to show my different cards inside my radio app. And the idea here was to remove as much as the HTML code so that we could actually have a nice and cleaner way to see everything. This is the same thing that you would do in UWP. This is what you would call a user control or a data template. Here in Blazor, it's called components. So I created a component that's called radio item component. It takes for parameter a radio item entity view model, which basically is just one radio item, and then it just populates. And so if we go back to my index.razor file, basically now I'm able to call this radio.item component, give it the specific item, and then I'm just able to populate. So I was able to basically remove 10 to 15 lines of view code and also be able to reuse this somewhere else if needed. So that was pretty cool. So let's go for a tiny demo about what it looks like as of now. So this. So here is the radio. Here is the radio item that I was talking about, the component. So this is what is being used to hold a radio item card. And it's called in the index.razor. So it would be called here. So this is actually with this a bit too much, so I don't. There we go. And so this item here is linked to, if it works. So this project might be broken, but I promise you I have one that's working. But this basically this radio item component is linked to this one, is linked to this basically. And so when I populate the radio item, it populates my items here and shows me nice video cards, radio cards, sorry, in my app. So let's go back to audio. Let's go back to the next one. All right, so adding audio. So in UWP, you can use, oops, a bit too fast. So in UWP, we have an element that's called media element, which basically allows you to play audio, video, MP3, MP4, HLS videos, and so on and so on. So for a UWP developer, it's really easy to consume these different streams. For the web, it's the same thing. You've got an HTML5 object, which is audio or video, which allow you to do the same thing. I decided to use Howler. I don't know if you guys have known about Howler, but basically it's a nice little library that allows compatibility with many different browsers and versions. So this simplified my life to get the audio working. It allows me to, it allowed me and allows me to play MP3 and AAC audios, which are mostly the main audio streams that I have on my radio apps, on my radio stations inside my app. So for Blazor, what happened is because Howler.js is a JavaScript library, someone very nice decided to wrap Howler inside a library, which he called howler.blazor, and basically it allows me in C# to call Howler.js elements. So I have This is not the correct one. So I have the component here. So howler.js. So basically, they incorporated howler.js code. We're calling the library, and then here we're basically calling back the different JavaScript methods. We're trying to get back whether it's a callback, whether it's play, whether it's sound, seek, the rate, the load. The wrapper around Howler is really cool. So this allowed me to gain a lot of time. So I can let you, if you guys are interested, don't hesitate to go on GitHub and type howler.blazor. This will help you a lot if you're trying to play audio files. They also have, there's another library, I don't remember the name, but that does the same thing for video if you're interested. So I decided to create a component. Basically, what I wanted was at the bottom of my radio application, I wanted to have a bar with play, pause, the name of the station that was playing, and the URL and any errors and the logo. So basically, I created another component that's called audio player control that will be set at the root element of my Blazor app, which will allow me to always have it at the bottom of my application, no matter where I go. Oh, sorry. Back up one. So I'm also injecting the different services, Howler and Howler Global. I'll show you afterwards the different how it's used, but basically this allows me to access the Howler wrapper that calls the Howler.js. And here is me adding the audio player control component at the bottom of my main layout.razor. So basically, this allows me to fix this element at the bottom of the app. So to manage all of my streams, to know which one is being played, to know when it's being played, what is it playing, is it not playing, what is its different state, I've got a stream playback service. It's a singleton that basically is calling the howler.js. So this one class allows me to actually pop up the audio player control. And so it allows the user to see the UI for the player. It can also be used to play the video, to play the audio, pause the audio, save to favorites, and also remove from favorites. So like I said before, at first, the application did not have any caching. I was able to find something really cool that's called Blazor local storage. This is done by Microsoft, if I remember correctly. So all you need to do is install the package blazor.localstorage, and it's going to allow you to store during the session content. So this is really good if you're actually looking to cache something, because this is going to allow you to store HTTP requests when the user is using the application, and once the user removes the application, well, this is removed because this is session based. So the only tiny issue that I found so far with Blazor is that you can't actually inject, you can't actually get local storage inside your class. You have to use it through a Razor web view, and then and then pass it on to your class. So what did I do here? I created and injected my iLocal storage service in my main layout so that it would only be created once. I passed this information down to my local cache singleton, the instance. And so basically after this, I was able to pass this, also pass this information to my services. So again, this is only from what I've been reading in the Microsoft documentation, this is only a limitation of today. In the future, they do plan on being able to allow you to get this without having to jump through hoops like I'm doing right now. So here's my singleton class. Very easy, very basic. All it's doing is that it's hosting and it's holding the iLocal storage service so that this can actually be called in my caching service afterwards. So nothing fancy. It's really, this is all there is to it. It would have been great that it would have worked out of the box, but I have to do this so far to be able to get the cache. And here's what I mean by being able to get elements from my cache service. So when I'm looking for cache, I have to do a local cache singleton.instance.cache. And then I say set item async to be able to get my item. Oh, sorry, it's the set, so it's to save it. If I want to get it, there's a get item as string. And if you want to remove it, you can also, you have an option to remove an item by key. So this was really nice. It allowed me to quite easily be able to re-implement my caching service. I did not go any further. I did not implement a database so far. This would have been some. I also saw that there were elements that allowed you to create databases, but so for my favorites and my history elements, that would have been really cool. But so far, I have not done this. So debugging, to be able as a native developer, being able to debug using Visual Studio is really important. As you can imagine, being able to set the debugger element at certain areas, to be able to check what the values have, to be able to see if a value is null, why is it null, where is it crashing, re-execute certain pieces of code. Visual Studio is really, really useful and very, very powerful. And so it was very important that in Blazor WebAssembly, you can also debug using your IDEs at first. So I actually tried this, I think it was 12 months ago, and the debugger, basically you were in the wild, and it's normal. It was at the beginning. Microsoft was still getting Blazor out the door, or it was still inside the door, not exactly ready to use, and basically the debugger wasn't working. So today we've got a debugger that's working on Chrome, on Edge. You're able to see where the errors are coming from. You're able to set a breakpoint inside Visual Studio when Visual Studio is working correctly, and so on. So that's really cool. So here's a nice little error that would happen when I did not instance correctly one of my MVVM Lite services. So basically, the error here was, well, it was the caching. This was at the beginning. I had not created a fake caching, as in the caching was not empty, so it was looking for cache and it wasn't finding this the service, and so it was crashing on me. So at least in the console debug, you're able to see where and what is crashing. And actually, today this would have actually, the error would have also popped up in Visual Studio. So that's pretty cool. So let's go back to the demo. So here, the idea here is just to show that I was able to use MVVM and HTTP out of the box. I didn't have to re-implement anything. Wait, do I have any? No, okay, awesome. All right, so where was I here? So first of all, is the app still compiling? So the app is being launched. As you can see, I'm not a great designer. I basically have kept all of the default design settings for this app. All right, so it was able to get me the different recommended elements. I can scroll. So that's cool. So the HTTP is working. I'm able to get my query. I'm able to get my content. As you can see, here are the different cards. I should have maybe shown a picture of what it should have looked like before I started all of this, but sorry. So now we're going to go over the different HTTP calls. So there's, where is it? So here we go. I'm going to start at the root. So at the root, I've got my view model, my radio dashboard view model that is querying. So I'm injecting my iRadio dashboard view model. I'm asking it to get me my content, which is here. So I'm retrieving the recommended radios, which is here. So this, so far we have not, we're still in the Blazor app. Still in the Blazor app. I'm faking the country and the language because I didn't go this far. So for the future. And now here I've got my API instance.get recommendation. And if I go here, I arrive in my API root, which is located in my audio.common. So it's located, API root is located here inside my radio.common. So we are able to reuse this. I'm able to do an HTTP request and I can get my different radios depending on the country and the language that I'm using. And then it's going down to make an HTTP request. Here we go. I've got my caching. I check to see if I've got cache. If I don't have any cache, I'm bringing. If I already have this request, I'm bringing it back up. If I don't, I do the query and so on. So that was the first tiny demo. Oops. So where was I? Small technical issue. Sorry. Here we go. So yes, so MVVM HTTP. So this is what we saw. Next, what are we going to see? The audio. So now, so what happens now is I've got, let's click on this Jacksonville, United States, Jones College Radio. So right now it's not loaded. I've got no error. It's trying to load this URL. And here we go. I'm getting audio in my headset. I don't know if you guys are hearing this. I hope not. But so basically what was happening is, I'll play it again. So basically what is happening here, I am right here and I am getting start in my component, which is here. The user is clicking on the radio card, which is sending back the information to my index. And then I'm hitting this start this radio command, which is using my stream playback service. And then it just basically starts playing this audio file. So once this is played, it's also accessed inside the audio player.control, which is here. Yes, so the audio player.control, basically, I didn't really go overboard on this. I basically copied and pasted what I found on Holler in their demos, and then just reworked it a bit to make it work for me. But the state and error messages, the URL and supported code, as you can see here, when I click on this, it tells me all of the supported audio files that can play. So that's pretty cool. All of this is done out of the box, thanks to Howler. And so here is the code linked to the Howler app. So when it's playing, all right, different callbacks. So on play, playing, loading, stopped, pause, and then different errors. For example, here I should be, I think it's this one. This one gives me an error, I think. My internet is a bit slow, so it's taking a bit of time. Is it Fox News that generates an error? today. Sorry, I'm trying to find a radio that doesn't work. Okay, this is even worse. Okay, they seem to all be wanting to play today, but so if I had an error, it basically would have shown me the error and the error type. So if I have Howler, for example, doesn't support HLS. So if I had a HLS radio stream, it would have basically given me an error saying that it doesn't support this media playback. Here are the different controls, and here we go. So on after rendering, what basically I'm looking at an event that's called playing a new radio, and basically once it starts playing, I set the different elements to display block and display none, which basically allows me to show this audio player to all to the user, because at first, as you saw, it was hidden, and then it was shown to the user. So what do I have in this play function? I'm getting all of the different codecs that are supported. I'm separating them and putting them in a nice little string so that the user can see, or at least this is more or less a debug so that I can see. Here are the different streams that I had fun with to try and test and make sure everything was working. So I've been playing around again. I found that all of the HTTP methods had to be replaced with HTTPS, or else I would get an error. So what do I mean by this is, no, I wouldn't get an error. I would get a warning. I would get a warning in Chromium telling me that it was upgrading it to HTTPS. So I prefer to replace the media source here from HTTP to HTTPS just to be sure. And then I'm informing that the state has changed. So let's go over this again. So I'm launching the app. The audio component is at the bottom. It's just not visible. And it only becomes visible once I click on a radio item, which is basically what I want. There. Next, what am I looking for? Go. So audio caching. Yes. So for the cache, what happened? Let's remove everything. Close all tabs. So for the caching, so like I said, where am I? Right here. So for the caching, I added this awesome NuGet package called Blazor.localStorage. Packages, Blazor.localStorage. So you've got to do your classic inject it as a service. So I added Blazor local storage to my program.cs to be sure that it was accessible everywhere. The thing that I had to do, or at least as of today that is not working, is to be able to access this local storage from inside a C# class. Because what I would have preferred is inside my cache services.cs, I would have preferred to not have to create a local cache singleton to cheat, and I would have hoped or preferred to just use cache service and basically directly access the cache iLocal storage service and not have to go and jump all these through all of these different hoops to be able to get my elements. But here, because as of today it doesn't work, you have to do this. So no problem. So what did we do? I went into my main layout.razor. I injected my blazor.localstorage.ilocalStorage service, called it local storage. Honestly, I just copied and pasted what was put on the GitHub. And when this page is initialized, I'm just sending it. I'm just sending the local cache to my local cache singleton up. Where does it? Anyway, so I can find it here. So I'm sending it here, and it's being stored, and it's being saved so that it can be used locally later on in my cache service. So let's go again. And here we're going to see with these different breakpoints, we are going to see, why did I, sorry, I'm clicking on everything here. And now we're going to see, here we go. So the instance is created, it's not empty. It's looking to set cache. So it wants to set this cache request. So basically what have I done is I MD5 the request. I MD5 the response. Oh, that was stupid. I MD5 the request, not the response. And I save the response. So I'm getting, and then I'm informing myself that I've saved it. And I'm telling myself that I'm looking to see if this exists. Saving it again. Saving the second one because there was 2 rows. And there we go. So as you can see, it's quite simple. It allows you to quickly access and quickly save and store data. So if I was to refresh here, it should. Oh, it is getting. Oh, so I must have done something wrong. 29D. Okay, so there's a little issue with my code. That is what you call the demo gods are not with me today. Oh well. So basically, what was happening is so the entity that was MD5'd, basically, I was hoping to be able to save this query, refresh the page, and then be able to get this data using a get cache entry async. But for some reason, I'm not. The saved query is not working. So I'll have to see what I've done. And that's about it. So as you can see, I've done a very simple. My UWP application looks like this by default. So I've tried to keep it more or less as simple as so I can save to favorites. So I did not implement this in the web app, but we can see that I've tried to stay as to the different design. I tried to keep close to it, to what it was. And when you click, it also loads at the bottom different audio. Here I've got more or less the same thing. So as you can see, it's a really work in progress. It's not at all production ready, but hopefully once Microsoft finalizes all of the different little issues that they have with oh, this is normal. Sorry, I left the breakpoints. So once Microsoft finalizes for production ready, maybe we'll be able to migrate all of these. Let's go to. So do you guys have any questions by any chance? I'm not seeing any questions. All right, so I'll just. If you guys have questions, don't hesitate to ask. So again, what was this? What was the idea? The idea of this was basically to show. Oh, I'll stay on. I'll actually put this in full screen if someone asks a question. Be able to see it. So the idea here was really to be able to see how quickly as a UWP native developer, you could have migrated your application. As you can see, for me, it was quite simple because my application isn't. It's not a huge application. It plays a radio station, so it's not really that hard to make. It did take quite a time to be able to understand because I had not done much HTML and web development before, so I had to really understand how it worked, how to make different things assemble one another. But other than that, it was quite straightforward. I moved most of the calls, HTTP calls, MVVM, view models, my different caching elements, everything that could be moved into this radio.common library was really helpful. It allowed me to reuse a lot of this code for the different elements that are passed, the different that are searched. This can really help you move along your different elements to generate a new app quite quickly. And so that was my journey. I first started doing this 12 months ago. It wasn't the same experience, I can guarantee you that. I replayed the app about a month ago when I heard CodeGen was doing this conference and wanted to see how much improved Microsoft had gone and their new releases, and I was quite happy. A lot of new things were working. Visual Studio was crashing a lot less. You still need to use Visual Studio Preview to be able to access all of the different bits. But other than that, everything is working much better. It's taking a lot less time, even though, as you can see, even on my laptop, it's taking a bit of time. That's because WebAssembly is basically sending all of the bits to my computer, and then it's loading. Here it's loading a bit faster. The HTTP calls are a bit slow. I'm still trying to understand why. But other than that, it's worked quite well. It's worked quite well for me. I'm going to remove these debuggers that are bothering me. At some point, it starts showing the radio elements. What else can I say? What else do we have any questions? I'm not seeing any questions. So if you guys are looking or are interested in joining Dailymotion, don't hesitate. Or if you're looking for, we've got jobs openings, so jobs@dailymotion.com. If you're interested at how we work here at Dailymotion, don't hesitate to contact me, Damien.Delaire@dailymotion.com. You can also find me on LinkedIn and contact me, no worries. LinkedIn, Twitter, or GitHub. Again, I'd like to thank CodeGen team for all of their help, and this is it. Am I not looking? Do we have any questions? I guess not. So I guess maybe I can go over some of what was the most complicated things to get the app working. So what can we do? So like I showed, error service is empty. Localization will just return whatever you're asking it, because as of today, there's no localization. My radio service, so I guess at some point I would have to add a database. So yes, let's go and look for that database. So where was it? Let's go and get this database information. There we go. So here's the repo for the local storage when you're in session. Yesterday, I saw that there was, for its local storage, but there was another one that was called sessions. I inverted them. Session storage. So actually, I'm not actually using the correct element for what I'm seeing here. I should actually be using this library to cache my HTTP requests, and I should be using the local storage to cache my favorites. That's interesting. It seems to be working exactly the same way as the other one. It's got a set item, the name, and the value. It's used the same way. So then would be interesting to see is WebAssembly. So that's perfect. That's what I've been using so far. Local storage serialization. Okay. So that's pretty cool. You don't even have to deserialize the element if you're specifying what type of class it is, unless you're using the specific get item as a string, which is pretty cool. It allows you to gain a bit of time, but for me, because I was basically just saving the HTTP response, I'm saving it as a string anyway, so I'm not in any hurry. Really, no questions? Is everyone sleeping after lunch? I guess so. Everyone's having a nice little coffee or tea. I guess it's 4 o'clock, so soon to be 4 o'clock, so people just want to. I could go into live coding if you guys want me to do live coding to add the favorites to see if is anyone actually listening? That is the real question. So seeing that I'm not seeing anyone, I guess that I'll just start coding and then someone will kick me out. Let's go for that. Let's go for coding. So let's do it. Let's do it like this. So what favorite radio DB? What's in there? Favorite radio DB. So I've got the ID, which is a new UID, and I've got my station ID. So guess yes. Remove this. I'm going to close everything but this. Up, here we go. I'm going to go in my cache service. So it's called singleton equal cache. All right, here we go. So first, let's start with get favorite radio. So basically, what does this do? This get, wait, let me not put this in full screen, just in case someone asks a question. I can see it in case someone asks a question. So what does get radio DB? Basically, it gets all of my radio items. So again, I'm going to make sure that the cache, so this is really badly worded, but here's my return error. Cache. Not eat. All right, so now I'm going to want and get all. What am I going to call this? I'm going to, yeah, but in the cache, is it, how is it? It's stored as. So I guess I'm just going to save. Should I just save the whole list? Serialize the whole list? Because it's not a database, so that's the question. It's saving it as a, I guess. How is it saved here again? Get item, set item, and it takes. Let's go and see this again. Let's go back to GitHub, local storage. What are the different options? Set item. I can't just. If I was just to do this. Oh, I guess I can't do that. Let's get the whole list. See if that works. Create a constants. I'm just gonna give it a simple name, 5. This is where it's going to be stored. Go. Here we go. Is this a, yes, it is async. So await, here we are. So what's the issue here? Of course. We are. Return. No. So this is how we would get all of our favorite radios in our database. So I guess to remove all of them would be as simple as this. Remove. Probably doesn't even need to. Here we are. Contains, well, that's quite easy. Contains. No. Station ID equals station ID. All right. And now for the fun part to add. So this gets all of the elements. This gets the ones that are stored here. Get them here. So, all right, so. Well, it's 3 minutes left, so I'm gonna stop here. But again, thank you for joining. If you have any questions, don't hesitate to contact me on GitHub, Twitter, LinkedIn, or by email at damien.delaire@dailymotion.com. It was a pleasure to do this session with you guys. And I hope you're all safe. Hope to see you soon in live. So we are about 1 minute before the end of the session. I would again like to thank CodeGen for having invited me to talk about UWP, my UWP application, how I was able to migrate it to WebAssembly. And thank you all for attending. I hope this was interesting for you and that you learned something. And have a great day.